Okay, everybody, let's go ahead and get started. I'm going to continue with the linear equations today. I'm going to introduce a new concept or a new term here, the slope, part of the linear equations. We'll first learn what the slope is and then see the formula. See a formula called the slope-intercept that involves the slope. So previously we talked about, we used the standard form, we used the equations that looked like this. We call this the standard form of linear equations. And we graphed these, we checked for solutions, and we did the x and y-intercepts and so on. So to graph an equation like this, or to solve it by graphing, we had to complete some table like this with what we call the x-intercept and also the y-intercept. And once we complete the table, we put the points on a graph and we draw the line. That's what we've done so far with an equation in this form, which we call standard form. We're going to do pretty much the same thing today, but with a different version of this equation, a much easier and much convenient form, which is much faster and doesn't require all this solving and completing the pairs and so on. So that equation is called the slope-intercept form. So this is the standard form. Today we're going to be talking about the slope-intercept form. Intercept, which looks like this. It's just another version of this. Basically, instead of having x and y both together on the same side here we basically isolate the y. The x is on the other side along with the other number. It's still the same equation, we just write it in a different form, and this form is convenient. We'll understand why later. Because it helps us graph quickly and get some other information about the line. We'll talk about that in a moment. Well, let's first understand the concept of the slope. The concept of the slope is better understood through a couple of graphs. So we give you a couple of graphs, a couple of lines, and you'll see for yourself what it means or what it does. So these are a couple of graphs. There's nothing on them. Let's put a couple of lines. Maybe one line. Let me see. One line that goes maybe like this.
Excuse me, what does it say next to slope?
Slope-intercept. Right? The same slope-intercept form. Okay, we need a couple of lines. So one that goes like this. Actually, maybe a different one. So maybe one line that goes this way. Another line that goes maybe that way. From here and up. Possibly actually make it go up this way. That's better. So we have two lines here. Let's call these two line 1 and line 2. So what do you notice just by looking at these two lines? What can you notice about them? What's different about them? Everybody? What exactly do you see that's there's a little difference here between the two. Without getting into too much technical details, just by looking at them, what can you tell? How different are they?
One went low, another went high to wide.
That's pretty close. That's the idea. That's right. So as you can see, this line and this line. So this one kind of goes is closer to the x-axis. So we have the x-axis, the y-axis.
And the
Or
other one is closer to the y's.
Right.
exactly. So this is, you see the angle this line forms with the x is smaller than the angle. This line too forms a wider angle with the x. This one tends to be closer to the x, but this one actually is much further than the x. So that's what the reason they're like that is because they have a different slopes. So the slope is something you can measure. Something is a measure basically to measure how steep, we say how steep the line is, how slanted the line is. So this line we can say is steeper because it goes higher, but it's closer to the y-axis. We say this line is steeper than that line. That's because they have different slopes. So the slope of this line is higher than the slope of that line. So it's something we can measure. We can find out mathematically, as we're going to see. So the observation is say line 2. So line 2 looks steeper than line 1. That's the keyword, steeper. So the slope, we can say, you can add to this, we can say the slope of line 2 is basically higher, is greater than slope of line 1. Is greater than slope of line 1. That's the mathematical difference. So the observation is, you can tell it from the graph. You can think of this as some treadmill. You know, when you are on a treadmill, you can adjust the incline. You can either leave it flat on the floor, or to make it a little harder to run or climb, you can lift it a little bit. You can adjust the incline. There's a button on the up and down button on the board of the treadmill that allows you to make it go higher or go lower. So you adjust the incline. That's basically adjusting the slope. Adjusting this slope, it's a number you can measure. So you can either run on a treadmill that's flat, or if you want to make it a lot harder with more resistance, you make it a lot steeper. Basically, you're changing the slope when you press that button up and down. And that's what the slope measures. So the slope basically it's basically a quantity. It's a number that we can measure mathematically. Okay, so slope measures the steepness. So we can say a line is steeper, or we can measure the steepness of a line. So the slope measures or calculates the steepness of a line. At least for these two, we know that the slope of this line is higher because this line is steeper. Okay, the steeper the line, the higher the slope. And to measure or to calculate the slope, we actually have a formula for it. So we can actually calculate the slope. We have the slope formula. The slope formula specifically just to find how steep or how inclined the line is. We call slope formula. Slope formula, which is pretty simple to use. So we refer to the slope as m. So m is the symbol for the slope. So m is basically y2 minus y1 over x2 minus x1. We're going to see where these values or the x's come from. So to measure the slope of a line, we need 2 points. To measure the slope of a line, we need 2 points belonging to that line. As we saw last time when we graphed, each point has x and y. So, for example, to measure the slope of line 1, let's take a couple of points. Maybe this one, and probably that one. And we have 1 here, we have 2, and so on. So let's try to get the coordinates of point A and point B. Let's get the y and x of both of them. Let's start with line 1. So we're going to measure the slope, calculate the slope for both lines. And as we expected, we said that the slope of this line is higher than this slope. So the slope is m. So for the first line, the slope, we're going to call it m1. We're going to find it. We're going to call the slope here m2 for line 2. We're going to find them. And as we said, from observing these, we expect this slope to be higher than that one. So let's prove that mathematically. Let's measure, calculate the 2 slopes and see if actually that holds true. First, we're going to get the coordinates of these 2 points. What are the coordinates of A and B? What are the coordinates? Meaning, what are the x and y of A and B? Start with the A. What's the x? Well, this should be actually 1 here, 2. It's 2, 3.
The x is
4,
2.
5. Okay, so the x is 2. If you drop it over the x, you drop it over the y. So the x is 2, that's the x-axis. And the y is 1.
1.
Okay, same way, let's get the coordinates of the other point, B. Always start with the x in the pair. So what is the first, what is the x value or the
5.
x?
That's a 5.
That's right, if you drop it here, it would be a 5. And of course, if you drop it over the y,
A 2.
to find the y, that's right, it would be
5,
2. So 5, 2. So that's all you need to measure, to calculate the slope of a line, or how steep the line is. And the formula says y2 minus y1, x2 minus x1. We get these values from here. So what you do is simply label these values. So the first point is called these x1, y1, first pair. And the second point is called x2, y2. But that's all we need for the formula. So I'm going to plug all those into the formula and simplify. So y2 minus y1, what would that be here at the top? Based on this, so what is y2 minus y1?
1.
Y2 minus y1.
It's 2 minus 1 on top, and on the bottom is 5 minus 2.
So y2 minus
2
y1,
minus
y2,
1.
2 minus 1 over x2 minus x1, which is
5 minus 2.
5 minus 2.
right? 5 is minus 2. So basically, you can start this way, but you can also start this way if you want, as long as you do both. But normally, so subtract the y's, this y minus this y, and then subtract the x's together. So another name for this, we say the change in y. Change in y, or simply the difference. Change in y, or difference of the y's. Change in y. So just subtract the y's in any way you want. As long as you do both the x and y in the same direction, you can do these minus these or these minus these same way. And of course, the change in x, change or the difference, we call this change in x. That's another way of remembering the slope. If you don't want to remember all these details and variables and x's, simply remember to subtract the y's over the subtraction of the x's. We simplify this, so this is 2. I mean 1 over 5.
1 over 3.
That's right, 1/3, which is about 0.66. It's just a number. The slope is a number. It could be positive, negative, decimal, fraction. Could be any sort of real number. So that's M1. Now let's do the same thing with the second one, do the same thing with line 2. We're going to measure its slope. We'll see. We'll see if that confirms what we talked about here. So as with the line 1, line 2, we also need a couple of points. Let's take that point. Usually takes a couple of points that are clear to read. You don't want to choose something here in the middle, would be a decimal. Choose something that's easy to read. What are the coordinates here? 1, 2, this is 2. This is about 3 here. Let's call these C and D. So let's get the coordinates of C and D for line 2. What are the coordinates of C?
1 and 2.
2 and 3 for
1 and 2 for C.
1 and 2. That's right. X first, 1.
And then
And
2
2.
and 3 for D.
That's right.
2 and 3 for D.
Good. So that's what we need. We need 2 points. For any line, we need 2 points. You can read them from the graph, or sometimes it might be given to you. Most of the time, I'll give you 2 points. You don't have to read them from the graph. I'll say, here are 2 points. Find the slope of the line that goes through these 2 points. All right, so we have the 2 points. What do we do next?
Plug them
We
in
use the
formula.
formula.
Right, so we're going to plug these into the formula. So this is M2. So again, remember to subtract the y's. You can
3
just do it right away.
minus 2
That's right. You can just subtract them right
over
away.
2 minus 1.
That's right. So 3 minus 2. And the x1 is x2 minus 1.
Minus 1, yeah.
This will be 1 over 1, which is 1. As you can see, as we expected, it's higher than this one because the second line is steeper. So this is 0.33. This one is 1. So this one is higher than this one because it's steeper. So it makes sense. So when you adjust, like I said, on the treadmill, you adjust this, for example, from 0.33 to 1. Basically, you make it more inclined or steeper. So you are changing the angle between the floor, the horizontal floor, the x-axis, and the surface or the surface of the treadmill. So that's basically what the slope is. You can see it, you can feel it. You can also measure it. Just like lifting something heavy or light, you can feel how heavy it is, and you can also measure it. You can put it on a scale and get the actual weight of the thing. Same thing here. We use a little bit of mathematics here and physics to find the slope of this line. And that's basically how you may measure the slope. So you don't have to read the points from a graph every time, unless you don't have any points, so you may need to read them from the graph. But most of the time, you'll be given points. For example, say find the slope or calculate the slope. I'll give you a couple of points. Let's say 2 minus 1, another one, maybe 3, and let's say so 3 and maybe 4. So as always, that's the formula. So M. So it just means we subtract the y's. You can label them first if you wish. You can say x1, y1, x2, y2. If that's confusing, don't worry about it. Just remember, subtract the y's together. So y2 minus y1, y2 minus y1, just subtract them together. So it's going to be y2, which is 4, minus, and then y1. What is y1 equal to?
Negative
Y1?
1.
Negative 1. So especially if you have a negative in the coordinates, these are the coordinates, you should pay extra attention because you could end up with a double negative like here. There's always going to be these 2 minuses here, in addition to possible minuses from these, from y1 and x1. For example, here, so we said y2, which is 4, minus here, minus y1. y1, which is here, happens to have a minus also. Okay, so we have a double negative. This is from the formula, this is from the y. So 4 minus minus 1. So we subtract them. So 4 minus whatever the y is. And then 3 minus 2. So 3 minus 2. So when you see a negative next to the coordinate, again, that means you may have a double negative. So don't ignore that negative. It's there for a reason, in addition to the already existing negative here. So that's the first step. So just plug in. So this minus this, this minus this. Then we simplify. So double negative turns into
Positive.
Positive.
positive. That's right. 4 plus 1 over 1. And that's 5. So whatever line this is, that's its slope. So this line is even steeper than the other two lines. It goes even almost vertical, very close to the x-axis, the y-axis. So it's not like the line 1 we saw earlier here in line 2. That goes even steeper, very close to the y-axis. So the angle here is wider. The angle with the x is much bigger than the other ones. So just remember, the higher the slope, the higher the slope, the steeper the line. And it could be a whole number, it could be positive, could be a fraction, which is a decimal, could be any number basically. It's just a measure, just like again measuring some weight. Weight could be decimal, could be I don't know, could be a fraction or a positive number. Now let me give you another example. So it could be negatives anywhere. It could be negatives all over the place. It's not always this simple. It's not always positive. So expect to have minuses all over the place. For example, let me give you another example here. So like we said, we may have a negative here, for example, and maybe a positive number here. And 7, for example, minus 4. 7 and 4. So same thing here, we're going to apply the formula. So m, what do we write at the top? If, in other words, the difference or the change in y. It goes here.
7.
7
No.
minus 4.
Yeah.
That's right. 7 minus 4. The y minus the y.
And
Over
then over
3 minus 2.
3. Negative
This.
3 minus 1.
That's right. This x minus the other x. And again, if this one has a minus itself, there would be another minus here, but this case is just negative. There's always a minus, and there's always a minus, and so minus 3 minus 1, 7 minus 4. Then simplify. So careful again with the signs, as you can see here, the slope and the sign also matters. The sign of the slope matters. I'll show you why in a moment. So you subtract these, you get 3 and
Over negative 4.
negative 4. That's right. You could put the minus in the middle. So the slope can be a negative number, as you can see. As a decimal, it would be 0.75. So slope is a number. It could be any type of real numbers that we talked about. And could be negative, could be positive. Let's understand when and why the slope is negative and why it's positive. So basically we have 4 types of the slopes. 4 types of the slopes based on the value of the sign. Before we move on to that, any questions so far, everybody? Everyone, any questions about any of these problems before we move on to something else?
How did it become 0.75, Professor? Again? I know it's all
Just one at a time. Hold on, one at a time. Mona, go ahead, Mona.
Yes, I forgot how did it become 0.75 again?
You divide, you do the division, 3 divided by 4.
Oh,
The long
okay.
division, yeah.
Okay.
Turn the fraction into decimal.
Yes.
Okay, Piero,
Where it-
what were you saying?
Yes. Where it says find slope, and there is m equal 4 minus times minus 1. We put the parentheses because it's negative, right?
You mean here?
Yes.
Yes, so if you have a negative, then another negative, you want to separate them with parentheses. So here we have 4, this minus from the formula here, and then the y1. The y1 happens to have a minus, so you need to write them like this. You can't write it minus minus 1. This doesn't make a lot of sense. So you have to separate them. So the first
All right.
y minus the second y. Okay, that's why we used parentheses.
Professor, question.
Mhm.
The formulas at the beginning of the class, where you have A and B there,
What about them?
what are they?
Standard form. Again, as I explained earlier, this is the formula we used last time. We turned it into a table, points, and we graphed it. The slope-intercept form is the one we're going to see after we talk about the slope. We're going to talk about the slope-intercept form. Okay, so that's another version. So as I said before, this is just another version of this formula. And this one is convenient, slope-intercept. Like I said, once we finish talking about the slope, we will go back to this and see how to use it. It's even easier to use than the standard form. So these are technically the same, but we just in different formats. So this one is more convenient. And we'll get back to it. On the slope itself, this is the formula for the slope. How to measure it. To calculate it, we use this formula. So before we go to this formula, let's talk about the types of the slopes. As I said, we have 4 types of them. So let's call this number 1, types of slopes. So to understand the difference, the 4 different types of slopes, we need graphs. I'm going to have a few graphs here. So we can visualize the difference of the slopes. And I'm just going to put some lines here. One line goes like this, the other one like that. The next one is horizontal, and the last one is vertical. Vertical lines. So here's all the possible types of lines or slopes. So the first one here, the line goes up. The line goes up from left to right. So we can tell just by looking here that the slope is a positive number. Whatever it is, it's a positive number. For example, this or this. This one, since it falls from left to right, it falls down like this. We can tell that it's a negative. We don't know the value yet, but we know based on the fact that it drops from left to right that this is a negative slope. So this is a positive slope. So slope or m. This one, just because it falls down, we know it's negative. We can find the value using this. We're going to need 2 points, plug them into the formula and find it. But at least we can tell the sign of it. So the sign here is negative. Positive, negative. This one here, that's horizontal. Basically, there is no slope. It's flat. It's horizontal. Basically, it's parallel with the x-axis. So in this case, the slope is 0. Okay, slope is 0. So whenever you see a line like this, flat or horizontal, know that the slope here is 0. And you can easily check yourself, take a couple of points, get the coordinates, plug them, and you'll see that this will be 0. And for this one, it's a vertical line. It's completely, that's as steep as you can get. That's, you know, the highest steepness, whatever you want to call it. So in that case, this actually has no slope. There's no slope here. It's just a vertical line. It's not a treadmill. You can't run on a treadmill like that. That's vertical. So there's no slope here. I mean, it's better term to use is the slope is undefined. The slope is undefined. So just remember that. Undefined meaning you won't be able to find it. Whatever numbers you try, you can try getting two numbers from here, 2 points. And when you put the numbers in the calculator, it will give you something weird, like undefined or error or something like that. You can try it later for yourself. You can have fun with it if you want. But just remember, when the line is vertical, the slope is undefined. It's not a number that you can find or measure. At least not a real number. It's not one of these. It's not a negative. It's not a positive or fraction, real, rational or irrational. Might be another type of number beyond all the numbers beyond the real numbers, beyond all the types of numbers we saw before. But again, I'm not going to overwhelm you with the details for now. Just remember it's undefined. Here, it's easy. Just look at it. You can say 0. At least here you can tell it's positive. Then if you need the actual value, take a couple of points. Do what we just did. Same thing here. We can take a couple of points and plug them into the formula. Okay.
I have a question, Professor.
All right. Go ahead.
The one you're saying slope is 0 or undefined, aren't the 0 slope, aren't they touching the y? It's horizontal, but it is touching the y, right?
It is going through the y.
I don't know if it's a stupid question, but
No, it is going through the y, yes. So the slope of it, when it's horizontal, it's 0. So I'll let you not discover, but I'll let you find out yourself later. Just take any 2 points from any line like this, plug them into the formula. You'll do the math, it will be 0. And this one, take also 2 points from here, plug them into the formula, you see that it's an error or undefined number. May not make a lot of sense, but when you do it yourself, you'll see that it checks out. Okay, so for now, just remember this. Just remember that this is positive, negative, horizontal. The slope is 0, vertical. The slope is undefined. And you can actually see from these lines, they both go up from left to right. So they both have positive slopes, 0.33 and 1. And this line definitely falling down like this. This line here, because it has a negative number, it falls down like that. Okay, so these are the types of slopes. So third thing is, now we're going to talk about the special formula we mentioned earlier, the slope-intercept. So instead of using the standard formula we used last time, we're going to talk about the slope-intercept formula, which is again a very convenient and easy to use formula compared to the standard one we used last time. So slope-intercept form. And that formula is, again, like this. So what makes it called special, or what makes it called the Y-intercept form, or the slope-intercept form, you will notice because the y is by itself. If the y is by itself, the other numbers, the x and the number, will be on this side. And the reason why we call it slope-intercept, because it literally gives us the slope. We can see it here. Okay, and also it gives us the intercept, or the y-intercept, which we talked about last time. The y-intercept again is where the y meets the line, meets any line. So for this line, this is the y-intercept, simply because the y-axis intercepts the line. So we call this the y-intercept. Same thing here for this line. This is the y-intercept, and so on. So the y-intercept simply means whatever line you have on the graph meets the y there. And this is also the x-intercept. This is the y-intercept, the x-axis. So this is the x-intercept we talked about last time. But today we're only going to be talking more about this. We're not going to worry about the y-intercept. We're more interested in this. That's why we have it here by itself. So the reason why this formula is convenient is because Just by looking at it, you can directly read the slope. You don't have to calculate it. You don't have to get 2 points and use the formula and so on. It's convenient because it gives you the slope immediately, and it also gives you the y-intercept, which means this is where the line, whatever line it is, it meets the y-axis at this point B. Could be 2, could be 1, whatever it is, that point is on the y-axis. Let me give you an example. So let's say 2x, 2x plus 3. So based on this formula, because it's in this form, what is the slope of this line? The slope m.
2.
2x.
And just
Okay,
2.
yeah.
Just the m,
Okay.
just the number next to the x, not the x. That's 2. That's it. So you can, there could be a question of say, what is the slope? You can tell exactly the slope immediately. But if I give you a graph, it may take a lot of time to find the slope. You're going to have to find 2 points, coordinates, plug them in, and so on. And of course, the y-intercept is
3.
y-intercept is 3, which means the line, however it goes, it meets the line it goes through this point. So the line, this line meets this is the y-axis, so it meets it here at 3. Could be going anywhere, this way, that way, anywhere it goes, but it has to go through this point. 3 on the y, that's why we call it y-intercept, and 2 is the slope. So to find out exactly which way this line goes, could be again anywhere, as long as it goes through 3. So we're going to need another point. We're going to need another point, for example, some point here, to know exactly how to draw the line. There's only one way to draw the line, one specific way. It can't be any way we want. So it goes through this point, and there is another point. But let's find where this other point is. We have to find out specifically where it is. So, and for that, we're going to use the slope. So we know that where this point is, it's on the y-axis. To find the other point, we're going to use the slope. So let me show you. It's pretty easy, actually. Show how to find the other point using the slope. So let me give you another example. If you take x, for example, and you say y is maybe 3 over 4 minus 5, for example. So again, this is slope-intercept form because the y is by itself. Whenever you see the y by itself, that formula is special and useful. Now, first, let's identify the slope and identify the y-intercept. So what is the slope of this line?
3/4.
3/4, that's right, 3 out of 4. The number next to the x. Whatever number is next to the x, could be a fraction, for example, 3 over 4. What is the y-intercept?
-5.
-5. No,
Negative 5.
5.
So that could be a typical question. Identify the slope and the y-intercept. That's it. And then another question might be to graph this, which is very easy, as we'll see in a moment. So to see how to graph this easily, so we already know that this point belongs to the line. The y-intercept is on the y-axis. The slope, 3 over 4, is made of 2 numbers. It's made of 2 numbers. Those numbers have names. The top one is called the rise. The bottom one is called the run. So the slope is always a rise on the run. If you don't have a fraction for the slope, you can always put 1. So the slope, when we graph, we need it as a fraction. If it's not a fraction, feel free to put 1. And again, that gives you the rise on the run. So let's understand what exactly we mean by that. Let me get a
What is it that you write there? Rise and run?
rise and run, yeah. We need, for this, we're going to need a graph. We need to be specific. We're going to need a graph so we can see clearly what's going on. So here's the fun part. It's how easy it is to graph this. Again, last time we had to complete tables, pairs, solve, find x, find y, and then we put the points on a graph. This formula actually we can graph in probably 3 or 5 seconds. We can graph the line. And this is how you do it. First, you'll find this point, which is again the y-intercept. So it's going to be on the y-intercept. So -5 is here. 1, 2, 3, 4, 5. So that's your first point. Okay, so that's again, that's what we call the y-intercept, or B. So we called it B, it's B, what is also called the y-intercept. So you start by finding that value on the y-axis. It's called y-intercept because it's on the y-axis and the line goes through it. Now let's go to the second point. So from here, what you want to do is, because this point here is called the rise, or go up, we're going up. So we're going to go up from here. We're going to go 3 steps, 3 units from this point. So we're going to go 3 points from here because we have 3. So we're going to say 1, 2, and 3. And we're not done yet. So we did the rise. So the rise basically means go up, or sometimes go down. And the run means go to the right. Sometimes go left. We're going to see when. So go up and go to the right from this number. So start from here, go up 3 units, that's the rise, then go to the right 4 units. So start from here, go up 3, 1, 2, 3. Then go to the right 4 units, 1, 2, 3, 4. That's our second point. It's exactly where the second point is. It's not random anywhere. It has to be in a specific place. So this specific line goes exactly like this. You can't put it anywhere else. It goes exactly through these 2 points, the y-intercept, and this is the second point, which we get to by doing the rise on the right. So start from here, go up 3 to the right 4, and that's it. All we need to do now is grab a ruler and basically join the 2 points. So try to be as accurate as possible. And that's it, actually. That's the graph. Again, this can be done in seconds. Just look at this. You say, okay, I'm going to start from -5, go up 3, 1, 2, 3, go up to the right 4, and that's it. Then you do the line. Quickly, no solving is necessary. Not even this is necessary, unless the question says, identify the slope, identify the y-intercept. If it says graph, you can directly do this in seconds. It's a lot quicker and easier than graphing an equation when it's in standard form like this, which we did last time. Again, we had to complete tables, find points, 2 or 3 points, put the points on the graph, and then join them together. But we prefer this one because it's convenient and easy to use, and it gives you the slope, it gives you the y-intercept. This does not give you the slope, by the way. This is not the slope. Okay, A here is not the slope because the equation is not in this form. The number next to the x is the slope only if y is by itself. If y is by itself and the x is in the other side, the number next to the x is the slope. But this is not the slope because both x and y are on the same side. This is the standard form. Does that make sense, everybody? This is not the slope. This is the slope when you have y by itself.
Question.
Okay, go ahead.
It's always rise. So it doesn't matter what number you have on the intercept, you always rise. So if you're 1 and you have to rise 3, you're gonna go to 4.
Right, so this rise here, even though it's called the rise, so sometimes we go down. So it's all based on the sign of the number. So if it's positive, we go up. If the number here is negative, so instead of going up, we go down. It's still called the rise, even though we go down. So this number is either up or down. That's all, either up or down. The run here, on the other hand, you either go right or go left, depending on the sign. So here we went right, but if you had a minus here, so
We're
instead
going
of
to the left.
going right, we'll go, that's right, exactly, we'll be going left. So
Okay.
that's the difference here. And this can be very quick. Again, to
Professor,
graph.
so why did it go down there? Why did it go down then, the number 4, negative run?
No, we didn't. This is for the rise. Both of these are for the rise. For the run, it's only right or left, depending on the sign. If it's positive, you go to the right, negative, you go to the left. So this number is the 1. These two here, up and down, are for the rise. Again, it depends on the sign. I'm going to do more examples of these. Everybody will see how this works more. So,
Professor, question.
mhm.
Does this applies for X-intercept, or that is completely different?
This only involves the Y-intercept. The X-intercept, you can see it here. After you draw the line, the X-intercept is here, the intersection with the X-axis and the Y-axis. But this one only involves the Y-axis. So to graph this, to find
So
the
we
rise
have
and
to
run,
find the Y's first, and the X is gonna go
eventually, yeah.
natural, eventually, yeah.
Yeah, so it may not ask you to find the X-intercept, maybe after you graph it, but you can see it from the graph. So we're only interested in the Y because we can graph the line quicker when we have it. So let me give you another example. It's not always, this could be negatives and positives everywhere. So for instance, Y is -2, X plus 3. So first, again, this is usually something you do just by looking at the equation. You don't have to write it down unless the question says identify the slope, identify the Y. But if it says graph, you can go ahead and graph immediately. But to make things simple and easy, let's first identify the slope, then identify the Y-intercept. What is the slope of this line? What's the slope of this line?
-2.
-2. If we want to write it as rise or run, as a fraction, what do we do? We're going to put it over 1. Now we have it as a rise over 1. And the Y-intercept is always by itself, this number. The Y-intercept is basically 3, +3. Now let's graph this. To graph this, where do we start from again, everybody?
The 3 on the Y
Positive
line.
3 on the Y line.
Exactly. So this is always on the Y, whether it's positive or negative. So 1, 2, and 3. So again, that's your Y-intercept. And now we just need to, from this point, from the Y-intercept, remember, from this
Goes
point,
up 2 times.
it does not go up, so it's negative this time. So
Oh, that's a negative. I didn't see the negative, sorry. Yeah, it goes down
Okay.
2 times.
that's right. So because of the negative, so instead of going up, we're going to go down. So it's called the rise, but doesn't mean it's always rise. It could be up or down. So in this case, it's negative. So from this point, we will go down actually. Then do we go right or left for this one? For
Right.
the 1.
Right.
That's right. So the 1 is positive, so we're going to go
Right.
2. That's right. If it was a negative, it would go to the left, but we go to the right. So start from here, go down twice, then to the right once. Start from here, go down twice, 1, 2, to the right once. And that's our second point. That's all you need again to graph the line. We need 2 points. You insert. So you draw the line that goes through them, and you have your line immediately. This takes, again, should take seconds. Once you practice it more, it'll take seconds.
Professor, excuse me.
Mhm.
What about that one number 1?
You
The-
went to the right once.
So we went to the right once. So we went
Oh,
down.
okay.
We went down
Mhm.
from here twice, then over once. Across from.
Oh, okay. Got it.
Or you may go
Got
over
it.
twice, 3 times,
Thank
whatever
you.
the step is. And that's basically how you graph how easy it is to graph the lines using this formula, which is convenient. So it may ask you to graph, like I said, or it may just ask you to identify these. You could just read them from the formula and that's it. And then another question might be to graph. Okay, everybody, any questions about these two graphs? Everyone, please
No.
let me know. This is again an easy way, convenient. We're going to need this in the future. We're going to use this for solving more problems because it's convenient. So I'll give you one more. I'll give you one more. And this time, again, it's always the y by itself. That's what makes this equation special. If it's not, the y is not by itself, then this does not apply. You use the standard form we talked about last time. What about this? -3 plus maybe 4. So in order to graph this easily, so try maybe identify your slope and y-intercept on the side first, even if the question maybe doesn't ask you, maybe you want to write them on the side to understand better. So what is the slope here?
1 over -3.
That's right. So the slope is an invisible one here. So it's 1 over -3. And the y-intercept would be is 4, +4. So when you see x, it means 1x. When you see -x, it means -1x. That's slope. That's the slope. So that's important. May not always be visible, but the coefficient, it is there, even if you don't see it. Okay, so in one sentence or two, how do we graph this?
You start from the 4 and on the y line, and then you go up 1 time, and then to the left 3 times.
To the left.
That's right. That's right. So again, we start from here, the y-intercept. You mark that point, 1, 2, 3, 4. That's the y-intercept. So go up from here because it's positive, then to the left this time because it's negative. Go up once, just once, then to the left 3 steps. 1, 2, 3. Vertically, I mean horizontally, not up or down. Sure, you go horizontally, and you can see the numbers here across from 3. So start from 4, go up.
-3 and 5.
That's right. So that would be here. So again, the y-intercept is here. Y-intercept, which is the +4. And that's it. Again, you just need to draw the line, insert the line using this, using a ruler. And when you do this, if you're doing it on paper, make sure you use graphing paper so you can have your accurate line and points. In the homework, you'll actually have the homework, the website, the lab will give you graphs. You can do this actually on the website. You can move points, put points, insert, just like I'm doing here. You will be able to insert lines and move things around, just like I'm doing right now.
So it would be a good idea to get graphic paper for the midterm.
Yeah, it's also good for practice. When you do the homework, practice your homework, do it on paper first. You know, it's always a good idea. But definitely for the midterm as well, yes.
Like this type of paper, you mean?
Yeah, you can print this out. You can buy it also. You may find a couple of sheets or a little book that has graphing paper, 99-cent store. Or you can just print it out. Print one that has 6 on each page. Or if you're good a little bit with, you can just make a little picture and put 6 graphs on it. Actually, you can find it online. Just type graphing paper with 6 graphs or something, and it'll give you multiple pictures. Choose one and just print it out. Okay, it's available. This I copied from the internet, so it's not easy to. It's not hard to find. Also, it's not hard to do yourself too. If you want to make your own graph, if you have a paper that looks like this, you can use a ruler. It takes you a few minutes, a few seconds to draw one, but You can use graphing paper if you want to practice more often.
Professor,
Okay.
Can you just, I was taking note and I didn't pay attention to the second one. Can you just tell me one more time, the second one, not this one, the middle one, this one. Yes.
Okay, so we started from 3.
Yeah.
And we went down twice. Went down because it's negative. Then went to the right. So we didn't have a fraction here. We added 1 to make it a fraction. So start from 3, go down twice, and to the right once. Started from 3, we went down twice, 1, 2, then over to the right once.
Thank you. Got it.
Okay.
But what
Professor,
about,
go up a little bit real quick.
Sorry?
Up. Go up a little bit.
Here?
Thank you.
Okay, any other questions, everybody?
yes, I have a question with the LATS exercise.
With what, I'm sorry?
The LATS exercise that we did, the last one.
Last one? Okay, 1 second.
Mhm.
Yeah, this one.
Understand, yeah, the number 1, which is, what do you, I'm trying to figure
When you
out what.
say x, when you say, for example, x, that means
Yeah.
1x. It's an
Yeah, I
invisible one here.
Yeah, I understood, but the thing is that where does it go when the picture?
all-
Where do you
so-
locate that?
So we started from here,
Uh-huh.
right? So this is the horizontal line. So we start from here, we went down once. Okay, otherwise we went up once because it's
So
positive
it's
1.
5, eh?
Yeah, so we started from 4, we went up once here. And then we went, because the 1 is -3, we went to the
Okay.
left.
Okay.
Okay, so we make 2 moves.
Oh, makes sense. Okay.
I have a question. The one you just made me understand, not this one, the middle one. What happened to the -2?
What happened to the -2? Again, we start from here,
Yeah.
we go down, we went down twice before going to the right once. So we start from 3, right? Then we went down twice, 1, 2, and then we went over. Okay, so we do 2 moves. Rise and right. 2 moves, the rise and the right. So from here again, the first one, so we start from -5. We went up 3. We went up 3. So that's the rise. Then went up to the right. Or basically we went up vertically. We went up vertically like that, 3 units. Then so this is a rise.
Thank you.
So that's basically how easy it is to graph using a rise and run. If the equation in this form, if it's not in this form, again, you'll have to find the intercepts, complete the pair, find this number, put the numbers in the graph, and then draw the line through it. So that's basically all about tonight's lecture, the slope-intercept form. So just to recap, understand what the slope is. It just means the steepness of the line. This line is steeper, more inclined than this one, because slope here is higher than this. We have a formula to measure the slope. All we need is 2 points from the line or 2 given points like these. Slope could be any sign, any number. So if it's positive, it goes up from left to right. If it's negative, it drops. If the line is horizontal, you can say that the slope is 0 immediately. You don't have to calculate it. You can just say it. If the line is vertical, just say the slope is undefined, and you don't have to do anything else. You can prove this again yourself. Take any 2 points. We've already done a few examples, but you can use your own lines, use your own graphs, and try to find this out for yourself, just like we did earlier. The special formula here, slope-intercept form. It is important because when the y is by itself, then it's called the slope-intercept form. On the other side, the number next to the x, not the x itself, the number next to the x, which could be invisible, is the slope. And the other one is the y-intercept. So to graph, we start from the y-intercept. the slope itself, we can write as a rise of 1. If the slope doesn't have a fraction, feel free to add 1. That gives you the 1, which is 1, means go to the right. And that's pretty much it. And you can start immediately graphing. You don't have to write any of this if the question doesn't say identify the slope, identify this. To graph, you immediately jump into the graph. Start from here, -5, go up 3 to the right. It will take you 3 seconds. But if the question says identify the slope and the y-intercept, then you want to write them down first before you graph. Let me know if you have any questions before I give you a couple of practice problems to do by yourself. Everybody, let me know.
Good.
Okay, so we're going to be using this again in the future for some other topics. So we'll come back to this later. So remember how to do these, how to do everything basically, because everything we do here, we apply for something else. So find the slope. So the first pair, the second pair would be maybe 3, 2. And we need 2 points, so I'm giving you 2 points here. So 4 and 7. So find the slope for these two. The second question would be identify the slope. Slope M. And
Professor, that's 4 and 7.
And the y-intercept. So I'll give you 2 equations here. So -x plus 4, and the other one would be -2 plus, let's say, 4. So first identify means just write them down. What is M, what is B? And graph actually, forgot to graph. Identify the slope M and the y-intercept, then graph. And graph the lines. So identify and graph slope and y-intercept. Could be done very quickly, especially the last two. Take literally no time. Also, these should take a few seconds. If you know what you're doing, if you've been paying attention, you should have no problem with this. Okay, so as always, I'll give you a lot of time to try this by yourself before we go over it together. You may take a short break if you wish. I know we've been talking for about an hour, over an hour now. So I'll see you in a few minutes. Everybody, are you done?
One more minute, please.
Okay.
Professor, I'm thinking that on the second one, on the second exercise, you forgot the X.
That's right. It should be an X always there.
But I took it like the X was there.
That's good. Yeah, it should be an X. I don't know why. Good. Put it or erased it. Should be X here. Okay, one more minute, everybody.
That's the question. We didn't hear you.
One moment. Someone said you need a moment to finish it.
Professor, can I ask you something?
Okay, go ahead.
When you gave us the types of slopes, is it possible that you give us an exercise that would say identify the slope or something like that? Because you know, when the graphic gave us something.
It would say something about what's the sign of the slope, or what's the side of the slope, or which direction the slope goes. Well, it could be another question that says find the slope. If it says find the slope, then you get 2 points and you plug them into the formula.
Oh, okay.
Okay. Everybody, so let's go over these problems. Okay, for the first one, what did you get here with slope?
5 minus 4 over
5
1
minus 4.
minus 3.
Right, 5 minus 4 over 1 minus 3.
Minus 3, that will be 1 over negative 1 equal to negative 1.
Over negative 2. 1 over
Negative 2 and then negative 0.5.
That's right, so that's a negative slope. You can write it as a decimal. So we know that this line falls like that. It doesn't go up, it falls. For the other one, what we write?
7 minus negative 3.
That's right. So 7
over 4
minus 3.
Yeah.
So there's always a minus here from the formula, and there's another minus because 3 happens to have minus. And
over 4 negative 2 minus 2.
Right, 4 minus 2. This turns
10
into
over 2. 10
over 2,
over 2 and then 5.
5. So that's a positive slope. So the line goes up from left to right. Let's identify. It says identify slope M and y-intercept first. What is M here?
Would you put like negative 1?
Minus 1.
Okay.
Minus 1 over 1.
Negative 1, that's right. Since you want to graph it, you need the 1. So you can always put 1. And the B or the y-intercept?
Positive 4. Positive 4 on the y line.
That's right. That's right. Then for this one, what's the slope?
Negative 3 over 2.
Negative 3, that's right. It's already a fraction. Y is overrun, so no need to make it a fraction. And the B or the y-intercept is
4.
Also 4.
You already put the thing in? You found which one?
Okay, so now let's graph. Let's put these on this graph. So the first one, so
it goes down 1.
So where do we start from?
Would you
first?
start at the y-intercept? 4?
Just start on 4.
You start on 4th on the y's line, yes. And then you go down 1.
So 3.
Okay.
And then you go to the right.
1 to the right, so that's 1 with 1. I mean 3 with 1.
Exactly. So we start from 4. So we went down, then to the right. Started from 4, the y-intercept, went down once, just one step, and also just one step to the right. And that's it. So now we join the 2 together. We can insert or use a ruler to draw the 2, to join the 2. That's line 1. Okay, so we need to do the same thing for the other one. So this is line 1. Let's call this line 1. Line 2 will be about the same thing. So we're also going to start from
4.
You start on 4.
And then you go to the left 3.
You go down 3 to 1.
Go down
You go down 3 times and then to the right 2 times.
That's
And
right.
then you go to the right, which will be 2. So 1
That's
and
right.
2.
So we're going to start from the Y-intercept 4, which is here, the same as the other one.
Yeah.
Then we're going to go down 3 units.
3 times
1,
down.
2, 3.
So you end up in 1, and then you
to
go
the right 2 times.
To the
you
right,
end
to the
up
right
with
twice.
2.
1, 2. That's right. So we have 2 points. Start from here, go down, then to the right. That's our second point. Let's do that with a different color. You don't have to do them on the same graph, but I just wanted to keep everything in on one screen. So it has to go through the 2 black dots on one line. So this is line 2.
Line 2 is steeper than line 1.
Line 2 is still the line 1. We can say that in terms of, so they both fall from one side to the other. So line 2 is steeper, yeah, it's closer, or the angle is wider, yeah, it's closer to the Y. So closer to the Y, the steeper, that's right. In this case, they both happen to be falling down instead of going up, but that's right. The absolute value of their slopes, this one has -4 and this one has -2/3. So the absolute value, if you remove the minuses, this one is higher than this. So therefore it's steeper. So that's right, that's correct. Okay, everybody, any questions about the practice here?
No, it was fun.
Okay,
No.
yeah. That's, yeah, so I'm gonna see this again next, the next couple of lectures to solve